Good evening, good afternoon, and good morning from wherever you're joining us from today. My name's Sarah, and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to another Microsoft Reactor live stream event. Today, I would like to welcome for the first time Ramon Perez. Ramon works as a Senior Product Developer at Decoded in the APAC region and also collaborates with Transform as a developer advocate. He spends most of his time developing educational data science content for work and for fun, teaching, drinking coffee, mountain biking, speaking at conferences, and exploring many of the outdoor wonders that Australia has to offer. So he is based in Sydney, Australia, just for a bit of background as well. So in this session, we'll be going through the metric stores and feature stores and the differences and similarities, why data professionals should learn more about them, and some of their use cases in the industry. So you'll see in the comment section there, for just a bit of housekeeping, I have put the check-in link with the event code 15114. Please do check in for tonight's session, where you'll find additional resources kindly provided by Ramon. So we'll be speaking for about 40 to 45 minutes with 10 to 15 minutes for questions at the end. However, do send us your questions throughout, and we will try and answer as many as possible. So I'm just showing you that check-in link slide there. This is also going to be on our YouTube live channel where you're viewing this right now. So there'll be an on-demand version available on our YouTube channel straight after today's session. But for now, without further ado, I'd like to hand the floor over to Ramon to begin. So thank you so much, Ramon, and over to you.
Awesome. Thank you very much, Sarah, and welcome everyone. Thank you very much for taking the time to, out of your Tuesday, especially after work, to come and hear me talk about metric stores and feature stores. I hope you take good content and good value from this session today. So without further ado, if you would like to access the slides, I believe they have been shared with you, but you can do so with bit.ly/mf/stores -stores. So all right, so let's get started. So as I mentioned, I currently work as a senior product developer at Decoded, and then I'm also collaborating as a developer advocate with Transform, which is a metric store platform. Decoded is a educational provider for organizations on everything related to data science and data analytics. Formerly, I used to work as a data scientist at Coder Academy, as a research associate at NCAT, and as a statistical programming instructor at London Business School. And then now let's talk about the learning outcomes for today. By the way, if at any point you have any questions, or please throw them in the chat. If I don't see them, or if I don't get to them throughout the presentation, then rest assured that I'll get to you at the end of it when we go into the Q&A section. All right, so by the end of this session, I hope that you will understand what metrics, features, and their stores are, learn about the problems these tools solve, understand what to look for in either store if you were to choose to adopt one of the solutions that we're going to talk about, and then become aware of how companies are using these solutions, and lastly, get a sense of the requirement for adopting one. All right, so let's look at the agenda. First, we're going to talk about what metrics are, what metrics, features, and their stores are. Then we're going to jump into why should you understand them and be excited about what they offer, especially if you're in the analytics and the data science space. And then lastly, we're going to talk about how do stores add value, what solutions are out there for us, and how do I figure out what to look for in them. And now let's start with the first section. All right, so let's talk about metrics. So I love this quote by Lord Kelvin. I should have put a picture of him. I believe it was 18th century or 17th century, someone in Britain. But anyways, it said, if you cannot measure, you cannot improve it. And that is one of the facts about metrics, or one of the things that they allow us to do. They allow us to measure things and improve them. So let's talk about some definitions of what are metrics. So here I have one that says, metrics are what companies use to measure, track, and improve the components that have a direct effect on their value proposition. So think about the product or service that the company offer. Revenue will be a metric that would track the success of that product or service. A standard for measuring or evaluating something, especially one that uses figures and statistics. If you think about a metric, an aggregated measure of how a product is doing or how consumers are using our platform and so forth, So that aggregation is, if it's aggregated to a single number, then that will become a statistic. A standard measurement, and a quantifiable measure that is used to track and assess the status of a specific process. We have reports, how many reports we send out, how many cold emails we send out. That might be part of a statistic. What our revenue is per month, how many client engagements we have gone through versus the amount of cold emails that we have sent out. How many clicks, the click-through rate of customers in our platforms, dating apps, user engagement in the apps, or for apps that have a different kind of business model. How fast can you get off the app? Then we also have delivery. How fast can we start shipping to you when you make place an order, either at Amazon or elsewhere? Then there's a ton of other metrics, and then there's also how fast after the delivery has gone out for the day, and you will receive your package that day, and it's in the truck. How fast will it get to your door? So those are just some examples of metrics that are important for businesses and that they determine something that adds value to your organization. All right, so let's talk about where are metrics. I mentioned dating apps. So in dating apps, one of the metrics that they track is daily active users. If you think about premium memberships like that of Spotify or elsewhere, or Netflix or Amazon, well, I believe Netflix only has a premium membership, but Amazon doesn't. Amazon Prime is a premium membership. So think about churn rate. How fast are people leaving us, or what's the rate at which premium members are leaving us? Clothing brands. Think about customer lifetime value. How much will I contribute in my lifetime to the revenue of, say, H&M, or pick your favorite clothing brand. News outlets. What's the web traffic? How many people do I get per hour, per day, per month, per week? All employees should, lastly, be happy at the workplace. So one important measure that some companies track, not all, is employee satisfaction through surveys or through any kind of medium that they would like to use. All right. So next, let's a quick note on a recent survey by Transform, which there was one of the questions that asked, which of the following metrics do you track for the teams that you support? And then out of all respondents, 80% said engaged users, or close to 80% said engaged users, about 75% said product usage, close to 60% said revenue, but I believe that should have been a 100%. I feel like almost everybody tracks revenue in some way. User retention, churn, close to 50%, and then revenue retention. I also added a link if you want to read about the results of the survey. So a quick note on two things which are often used interchangeably, and you probably use them every day. I know I use them every day, and they are very important, but they have a few subtle nuances or subtle differences. One is that metrics are tied to the success of a company. KPIs are tied to the specific goals, such as the success of an ad campaign. Metrics are a data point, things that we aggregate over time. KPIs are frequencies or aggregated numbers that provide a direction towards achieving a goal for a specific campaign, for a specific product, for a specific service. It doesn't necessarily mean I track a KPI on how the health of my company is doing. Metrics are used to track a company's financial health, among many other things. And then KPIs can change regularly for similar or different goals that may or may not affect the revenue of the company. All right, so what are the characteristics of a good metric? So they have a clear goal, they are actionable, they are readable. Can you look at a metric and understand it immediately? They have a consistent definition, they are measurable, and they are relevant to the bottom line. All right, so now that we know what metrics are, now that we have a framework to think about metrics, let's talk about metric store. And the reason why I have behind here, I want to give you an analogy. The reason why I have a metric store before I dive into the definition of one, the reason why I have this supermarket in the background is because I want you to think of metric stores as a supermarket. When you go to Woolworths, or when you go to Kohl's, or when you go to Walmart or Target to do your grocery shopping, you expect to find the exact same items. You expect to find bread, you expect to find salad, you expect to find onions, and so forth. You don't go to the supermarket and searching for avocado, and they tell you, hey, we don't have it, take a line, or something like that. So you expect consistency from the products that you see being available at the supermarket. And in the same way, in a metric store, you expect consistency of the things, of the metrics that affect your bottom line, or that affect a particular part of your business or a particular part of your product. So I want you to hold that thought in your head. All right, so let's talk about what a metric store is. A metric store is a tool that allows you to define metrics as code, govern them, and serve them to a variety of downstream applications. And you might think, okay, so metrics as code, govern them, serve them to a variety of downstream applications. What are you talking about? We usually open up Tableau, Power BI, if we're on the analytics side, or a Jupyter Notebook. We write our SQL query, we query the data from a data warehouse, and then we bring it back to our application, and then we're good to go. We start deriving insights from. All right. So first we got the data sources. Maybe it is multiple databases, and then all those databases get combined into a data storage or a data warehouse or a analytical warehouse, where all of your analysts or all of the people that consume data for analytics purposes can access data from. But then we have the metric store. So the metric store sits as a layer in between your data storage and your data analysis tools. And the nice thing about that is that you can, once a metric is defined, its definition, its dimensions, and how you measure it, then you can forget about having to write those SQL queries, and you can just go and click and drop depending on the type of application that you're using, or just write a one-liner and get the exact data you want based on the features or based on the metrics that you are interested in. So also, this process assumes an ETL approach took place. One of the popular ways of approaching any kind of data movement at an organization nowadays is also ELT. And then I'll show you what that looks like in a second. So in addition, metric stores allow you to productionize data for diverse business use cases and stakeholders of varying technical levels. What does that mean? So first off, I mentioned that I was going to show you the difference between the ELT and ETL. So ETL means that I extracted the data from my data sources. I transform it in a way in which it makes sense to load it into my data storage. And that way, whatever transformation happens after that is most likely going to happen either in the metric logic or in the metric store, where metrics have been defined, or in the tool that your data analyst or your data scientist or your data professional is using to do some analysis. But in ELT, we take all of the data sources, we load them wherever we want to have them all at, and then we write a transformation query or a transformation some transformation lines of code where we can just say, hey, this is the process that I want to use when I put them at X place. In this case, into the metrics. All right. So what was it like before that? Now that we know that metrics is a layer in between your data sources or your transformed data and your downstream applications like BI tools, Jupyter Notebook, and any kind of tools that you want, Tableau, Power BI, whatever. What was it like before that? So before that, each use case will have its own metric logic definition prior to the analytics stage. So you will still have the data sources. You will have a data storage where all your data will go at, and then you will have a metric logic right there and there with your data analysis tool. So for example, if you spin up Tableau, if you spin up Power BI, you write a query to access, you're connected to your data storage, you write a query to get the data that you need, then you start doing your visualizations and so forth. So you already spent some time writing that query, unless you already had it from somewhere. But if this is a completely new use case, then you're probably writing a query and you're partitioning your data by different dimensions. For example, if I want revenue, I need sales, I need cost of goods sold, I need time, I need maybe I need gender depending on my brand, maybe I need age or age brackets or age buckets. All of those are different dimensions by which you can split a piece of data. So that's why here I have the view of little cubes moving along, because once you start adding dimensions, your data start looking more like a cube rather than a two-dimensional plane or graph. So now that we know what metrics are, what did they used to look like? What problems do they solve? So the first one is inconsistent metric definition across teams. For example, the finance team might have a completely different definition than the marketing team or the sales team on what revenue is. Maybe not necessarily revenue, but maybe about churn, maybe about the customer lifetime value, maybe about any kind of other metric. Some teams might have different definitions, and you want them all to use the exact same metric when they make their reports for the health of the business, how things are going, how things are moving, and so forth. So wasted time writing queries, code, rather than insights. So I mentioned that a lot of analysts, they open up the tool, their tool of choice, they write a query, they get their data, they get to analyzing it. Then if you already have those definitions made in a single place, then you can just access your data with either drag and drop or one line of whatever the API that metric layer uses is, or however it goes. So inaccurate values at the time of reporting, I mentioned having different definitions for different teams, but also the reporting side is the most crucial one. If I say, hey, this experiment, this ad campaign affected revenue by this much, but then another team, sales, said, hey, these 2 new salespeople added this many calls to the pipeline, and now we are at X amount of revenue or engagements per call, affecting revenue in X way. So on traceability of code and queries, I have been guilty of writing queries myself where I don't know where they end up at. Then lack of governance and trust. Who created what, when, and how? If we have a metric layer or a metric store, we can always know who created a metric, who defined it, who put it there, when and how. When was the last time that metric got updated? Does it need updating? If it does, are we duplicating data if it does need updating? And also, every time we hit our data warehouse or we make a query to access data, if it's a lot of data, are we increasing our costs of cloud resources? All right, so also from the survey, that was what kind of problems the metric store sort, but also from the survey, what would you like to achieve? We asked, what do you like to achieve when reporting on metrics? And some of those are the exact same things that I just mentioned. Eliminate ad hoc repetitive tasks, bringing more capacity to your day job, deliver faster time to insight to business teams. So cut time writing queries if all of that can just sit in one place wherever you need them, when you need it. Democratize access to metrics. So for example, if there's a metric layer, not just people who can write SQL queries can access that data, but also people who don't know how to write SQL and use Excel for their data analysis purposes. Increase trust, confidence in the analysis. If the metric has been defined in a company-wide way, then we know we can trust it. We know everybody agrees on a standard definition. And provide an interface to consume data from other teams or part of the organization, lower computational costs, and so forth. So how do they work? Connect to the flavor of warehouse or database available to your organization, at your organization. Then the data producers define metrics as code in multiple ways. Then the downstream tools connect to your store. So how does that look like? Well, so we have data producers, we have the metric store, we have the downstream tools, for example, Power BI, Grafana, Data Shaded. Then we have SaaS applications like Mode, Salesforce, Optimizely. Then we have ML tools like Jupyter, R, Hex, Amazon SageMaker. But then we also have the product team, the marketing team, the finance team, being able to access all of these tools, or all of this data and all these metrics with the downstream tools of their choice. All right, so who uses metric stores nowadays? This is a fairly new product and service in the data analytics space or in the data analytics tools building world. But there's companies that have been doing this for a few years now. The first one being Airbnb, who created Minerva. It is a closed source, so it is only available at their organization, but they have had several articles talking about how Minerva works, and I highly recommend that you check them out. One is how Minerva achieved metric consistency at scale, where they go over why they adopted Minerva. So for example, they needed to have the same metrics. Airbnb is a marketplace, and they need to make a lot of experiments on what works. How can we interact with the users better? How can we make our website better? So they're constantly testing creating experiments that affect some sort of metric as the organization. So it became so apparent that there were thousands of metrics and that they needed a place to store them all at, so that nobody will have to create an experiment and then go and backtrace and go and find that metric to then compare results to the bottom line of the business. Then there's a second article as well that is really, really good, and it's how Airbnb standardized metric computation at scale. So we talk about, okay, so now that we have the metric layer, how do we scale it? And why do we scale it? And what's important about it? Then LinkedIn has UNP, or Unified Metrics Platform. They don't have that much written on it, but they do explain a little bit about it in their website, in their engineering blog. And then Uber actually has a couple of articles on their metrics, and one is the journey towards a metric standardization. Their in-house tool is called UMetric, but they recently open sourced a tool called M3 that allows you to plug and play immediately your data and your metric layer to Prometheus and other tools that allow you to use to create a layer between your downstream applications and your data warehouses. All right, so now let's talk about features. So I gave you an example with a supermarket, and now I want to give you an example with features. And the example with features is think about creating a process. If we wanted to automatically generate pizzas, and all we have is the ingredients of a pizza, we need the process of that pizza. We have the process, and we need the ingredients to create those pizzas. So the ingredients in this case, if we wanted to create something that would automatically create pizzas for us, say a machine learning model that would learn how to take some features, some input data or some input ingredients, then those ingredients that will go to that model that will then give us a full pizza will be the features. So features stand for the data that you pass into a machine learning model. So let's talk about first, before defining it, let's talk about what the machine learning workflow might look like. Different organizations, from the data scientist, from the machine learning engineer, and from other people creating these models. So first you have a problem, you have a goal, then you have some data sources, then you have to prepare that data, then you have to create features, so the data, the input that goes into your machine learning model, and then you need labels, or you need whatever information you're trying to predict. Then you need to train a model. Then you need to evaluate it. Then you need to fine tune it, and then you need to train it again. And then you need to evaluate it, and then you need to fine tune it, and then you need to train it again. Once you're satisfied with the training process, then you usually deploy it. And you have people interacting with it, either inside your organization or outside your organization. But then after you deploy it, then you have to monitor it. Have things change? After I deploy, 2 months after I deploy my first model, has the training it again, once a month have passed or whatnot, has that kept us getting the exact same results for what we wanted to do? And then after you monitor, you go back to your data sources and you go back to your features and labels, and then you do it all over again when you're trying to train again. So that's, in a nutshell, what a machine learning workflow might look like at your organization or at many organizations. So then what are features? So features are a numeric representation of raw data that serves as the fuel for a machine learning model. So that is the source, the fuel, the gas, the petrol. But what do they look like? So here in this table, we have student, yes, no, whether. So we have in the rows, we have people. And then in the columns, we have features, or we have information, characteristics about those people. One is this person a student or not? Another one is what month of the year did we took this information? Another one is what's the income of this person? So that right there is not a feature. But then if you look at on the right hand side, then we have student. So now we have a 1 for whether a person is a student or not, and a 0, if it isn't. Then we have the months with the respective numbers, February, the number 2, and then income, instead of having a K, instead of having a $sign, now we have the actual amount spelled out. So those will be features that will go into a machine learning model. So how do we create features? Well, one of the ways in which we can create features is by recoding all non-numerical values into numerical ones. So for example, think about a Likert scale question. Whenever we ask you, did you like something? How was your experience with XYZ? And you say, well, you get 5 answers: very dissatisfied, dissatisfied, neutral, satisfied, and very satisfied. Well, what does that look like? Well, before that becomes an actual feature, it usually looks like satisfied and dissatisfied, the name of the option that you selected. But after you make it a feature, then it becomes a 4, a 2, or whatever logic you want to use to recode it. So I've seen it where it's -2, -1 for very dissatisfied and dissatisfied, 0 for neutral, and then satisfied is a 1, and very satisfied is a 2. But however you want to do it. Then by extracting information from different data points, for example, dates, not those dates. Here we have the 31st of December of 2021, 2 p.m., 2:22 p.m., 55 seconds, the 20th of July, 2021, 11 a.m., and 11:40 a.m. And then if we want to convert that into features where we actually extract each one of the components of that day, we take the day, the month, the year, the hour, the minute, and the seconds. So then that was structured data. But what about unstructured data? So here I have 3 dad jokes. So how did the picture end up in jail? Well, it was framed. I made a pencil with 2 erasers. That was pointless. Where do lizards go to fix their fallen tails? To the retail shop. I hope you laugh about it. All right, so how do we convert them into features if it's unstructured data? So one of the ways in which we can do it is by taking the bag of words representation. The bag of words representation takes every single word without replacement from the corpus of data, or the amount of articles or sentences or jokes that we have, puts them all into the columns. Then each one of the jokes become a row, and now we're counting the frequency or the amount of times with which a word appears. So that's why here you see the number 1 for did, do, one, did, do, and, to, of, was, and so forth. So those will be features for our machine learning model. Okay, so now that we know what features are, what is feature engineering? Because we know that a feature can go into a model, but we don't always want features as they come. We sometimes want them in a more particular way, or in a more information-full way. So feature engineering is the process of formulating the most appropriate features, given the data, the model, and the task at hand. This comes from the amazing book, Feature Engineering with Python, from Alice Sain and Amanda Cesari. And then another one is, it is using domain knowledge of the data to create new features that increase the signal coming from the data. So for example, if we have 10 different features and some of them are not necessarily usable for our model, then we might not want to extract them. Or if they are used, they can be useful for our model, but they don't necessarily have to be all alone or in isolation. We might want to combine them with some sort of logic, and that will be a part of what feature engineering is. Okay, so feature engineering is important because it helps us capture subtle to complex relationships in the raw data, increase the accuracy of our models, get rid of duplicate features, reduce the magnitude and scale of the features, deal with outliers, and reduce the dimensionality of our data. So for example, if we have 100 features, we might be able to bring them down all the way to 2, 3, 4, 5 with some sort of dimensionality reduction technique like principal component analysis. All right, so how to select a good feature set? Now that we know what features are, what feature engineering is, how it can help us, how do you select a good feature set for your machine learning model? Well, you strive for simplicity, you select independent features, so something that is not correlated with one another. So for example, if you have height or not necessarily height, but if you have the income of some people in your data set, and you have it in terms of US dollars, and then you have it in terms of Australian dollars, then you certainly don't need those two features. If you have height in centimeters and you have height in feet, then you definitely don't need those two things to represent the same thing. If you have, avoid useless features. So for example, if I'm trying to predict whether I'm going to give a loan to an applicant, I work for a bank, I'm creating a model that will determine whether I grant a loan application or not, or whether my bank grants a loan application or not. And some of the things that I might want to know about the person applying is, do they have a job? Do they, what's their income? What's their age? what's their maybe their location, where do they work, what kind of industry do they work in, and so forth. But one of the things that might be useless might be, what is their zodiac sign? That might be, there's no way that can give any signal to a machine learning model. So that would be a useless feature. Avoid redundant features, and I mentioned that a second ago. And also pick a good starting point for your minimum number of features that your problem will need. So if you don't know how many do you need, and you have a countless amount of features that you can play with to solve a problem, then you might want to start, how many do I need as a person with my brain to actually start solving the problem and predict whether a person has or not, or could be, or a good successful applicant for a loan. Okay, so I believe I have, yep. So now let's talk about feature stores. So earlier I gave you the analogy of the supermarket with the metric store. Now I want to give you the analogy with a feature store of a clothing store. So yes, we will have t-shirts, we will have pants, we will have, we might have shoes, we might have accessories like watches, necklaces, and so forth. But these features or these clothing items, they're going to change season by season. So whenever winter hits, then we're going to see more long sleeve stuff. We're going to see things that are warmer. And then by the next time the spring hits, then we might not see any of the items that we saw the previous year. So that's exactly the same with, or not exactly the same, but somewhat similar to a feature store. We might update our product from version 1 to version 10 in the lapse of 2 years. And a lot of the features that we used to track might change over time. And we might have to create new features or change the definition or the ways in which we define those features that we used to have. So that's sort of the same. So in a metric store, we want metrics to be long-standing. In a feature store, it doesn't really matter. What we really care about is, what are the most important features for our model, and how can we have them available whenever we need them available. So let's talk about feature stores. So here I have an excellent quote, or an excellent definition by Willem Pinar and Mike Del Vaso. Willem is the creator of the first open source, or one of the co-creators of the first open source tool, one of the first open source tools for feature stores. It's called Feast. And Mike Del Vaso is one of the co-founders of Tecton, one of the first companies specializing solely on feature store, commercial feature store offerings. And here they go. So they say an ML feature store is an ML-specific data system that runs data pipelines that transform raw data into features, into feature values, stores and manage the feature data itself, and serves data consistently for training and inference purposes. So let's disentangle all of that. First off, what problem do they solve? So redundancy when building features. We talk about how we build features. So we talk about how we don't want to have redundant features whenever we create it. So we want to avoid having redundant features. So another problem that they solve is slow online serving. If I have a machine learning model whereby the user is inputting some data, they're interacting with our services, they write a word, that word has to be translated into a number, or they select some type of application, they click on an ad, they do something that doesn't translate immediately into a numerical representation, then that has to be translated, or that has to be transformed into a numerical representation so that we can provide the user with a prediction on the spot. The scaling of large ML models, discovering new features at scale, the monitoring of our feature pipelines health. So remember, a feature store is a combination of data pipelines that transform our features and makes them immediately, save them and store them and serve them. So it monitors those pipelines. And then another problem is having to provide extensive engineering support whenever we change our features from this definition to this other definition, or we come up with a new clever way of defining features. All right, so that is what the problem they solve. Now let's talk about how do they work. So first you have your problem and your goal as before, but then you have to get the data as before from your data sources. But then now you have two things. You have online, so near real time, or as close to real time as it might be, that you need the data available for. And then you have batch data. So imagine batch data saying, I'm going to retrain a model, or I'm going to update the data source from where my model gets trained weekly, nightly, monthly, whatever. So we have batch data or offline data, and we have online data, data that's needed to make predictions in real time or near real time. Then we have the feature store, where we define and register our features. We transform them to make them usable by our models. We serve them to our models to make predictions, and then we share and monitor them. And this is one of the best propositions about feature stores, is that if you have a centralized repository where your team can connect to and get the features, then they don't have to think about writing the code and writing all of the code and all of the functions that might go into that pipeline for them to extract value and create their models. And then the monitor part, not all feature store solutions offer it, but it's a very nice to have part. And I'll talk about that in a second. Then you have the model. Then you have all your scientists, ML engineers, ML ops people interacting with the model, with the feature store, and with the feature store back and forth. And then you deploy it. And because the feature store can monitor the distribution between the features that you have offline and the ones coming in online, or the ones that haven't been used to retrain your model, then you can see whether there is a feature drift or distribution drift between the same feature or not. All right, so who uses them right now? So you have Spotify has Jukebox. There is a great talk in the Feature Store Summit, and I believe you will receive the link to that, but you can also just go to YouTube and find it, where they go over how, why, and the use case of Jukebox at Spotify. That's their Feature Store solution. Airbnb has a tool called Zipline. Gojek was Creative Feast, and it was first a closed source solution, and now it's open source. Uber has Michelangelo, Palette, and then Netflix has Metaflow. All right, so why should you understand them and be excited about what they offer? All right, so why do we need metrics? First off, before we even talk about stores, let's talk about why we need metrics. So metrics are the shared language for organizations to make decisions on. It's something that gives us a way to understand how the bottom line of our business is doing. So it helps us measure and improve business outcomes. It helps us to track how the evolution of our products and services affect the bottom line, to test the effects of new products and services in different areas of the business, and to understand our customers' behavior, and also to spot dips and spikes in performance and prevent churn and turnover. You can think of those spikes as seasonality trends. So, for example, at a retail store, Christmas is coming, or Thanksgiving in the US is followed by Black Friday, a big time to shop, even here in Australia. And then dips might be after any of those dates. All right, so why do we need features? Now that we know why we need metrics, why do we need features? Well, to represent raw data from the real world, to train machine learning models, to improve our products and services with machine learning, to understand our customers' behavior, to provide recommendations to our consumers. All right, now why do we need the stores version of it? Now we know why we need metrics. Why do we need a store? We want to standardize the way in which the goals are tracked within the organization. We want to make sure every team, no matter where they're at, no matter what they do, no matter who they report to, if they use revenue, they use the same definition of revenue. If they use churn, they use the same definition of churn. If they use whatever KPI or whatever metric they're tracking, they use a consistent definition across the organization. We also want to apply well-tested software engineering best practices to our analytics function. What does that mean? Applying software engineering best practices means that so the code that you define for a metric is actually defined in two particular ways, either YAML files or SQL queries wrapped around a data model or an API. So for example, like dbt or something similar. And we're going to talk about that in the solution sections here in just a second. So when you define metrics as code, you get to apply software engineering best practices. You get to version control the code that created your metrics. And if somebody wants to change that metric, they have to submit a pull request to someone in the team, and then that pull request has to be reviewed, and then has to be either accepted or not accepted, and then merged to the master version of your metric store. To let our visualizations and reporting tools do what they do best and move all the metrics logic to a single place. to stop duplicating tables at the warehouse level at the time of metric logic definition, and because the amount of teams doing and taking advantage of analytics across the organization continues to increase. That's probably one of the biggest ones. The more people in your organization that interact with data in one way or another, the more you're going to need a way for enabling them to access it. And not necessarily all of them can write SQL queries or connect to a database in a seamless way. Why do we need feature stores? So to reduce the latency between getting raw data, transforming it, and making a prediction. To stop duplicating features for the same purposes. So let data scientists share the features whenever they create them, especially if they're creating models that have where the signal comes from similar values or similar interactions of our users of the users with their platforms. To automatically backfill newly selected features as needed. For example, you get a new feature and you don't have any values backfill for that feature, then the feature store will allow you to backtrack and go and get data for whatever time period you define for. To detect drift between data sources, and because serving predictions in real time is hard. All right, so let's talk about the advantages of a metric store versus a feature store. So, or not versus a feature, because their advantages are pretty much almost the same. So you get to automate the creation of these metrics and features. You get to build trust among end users with consistent definitions. You get to enable software engineering best practices. You get to share those metrics and features. You increase experimental and productionization velocity. One of the key things for Airbnb, whenever they introduced Minerva as their metric store, was that it was mostly needed for, or not mostly needed. One of the biggest components was that they experiment day in and day out with new features, with new things that they give to their to hosts, just as much as the things they give to people that want to stay at an Airbnb place, at a listing. So automatic backfill of metrics and feature computation and logging, increase consistency between training and serving data, that's mostly for the features, and then reduce costs. Abstract away the complexity from multiple data pipelines. Now, what are the disadvantages? One is that feature stores do require an advanced level of engineering to get it set up and running. Metrics can have a steep learning curve for data professionals without a coding background. Why? Why is this? Because out of the solutions that are out there, usually, as I mentioned, you write a combination of YAML files or SQL queries or some sort of abstraction model like dbt on top of your transformations or on top of your logic that defines your metrics. And maybe all of those things, especially version control, might not be as easy for somebody without a coding background to actually go ahead and use to their advantage. Also, complex feature creation in real time is still a challenge. The metric store is still the early days, which means that a lot of testing and development is still in progress. And then for feature stores, it is easier to adopt for big companies than it is for smaller companies. Then handling large data sets can be a challenge with the metric store, and handling thousands of features, not necessarily millions of data points, but thousands of features can be a challenge for a feature store, especially on the manual side of things. Whenever you're trying to set up, okay, these are the features that I need, this is why I need them. If you were to have to write that config file manually, or of course, not manually, but put all those features in one place, that could become very cumbersome. So what are the similarities? Well, they both work best and are optimized for structured data. So, which means that not being optimized from structured data is one of the disadvantages as well. In both, you can define things one and use them everywhere. We talked about that many times. I really want you to take that in with you. Update your definitions one, and then changes happen globally, which means metrics and features get backfilled. I talked about how if you write the logic for a metric or for a feature, then you version control it, you write a pull request, you send it to your team, somebody revises it, and then once it gets approved, then you get to push those changes and the metric has changed or the feature has changed. Both act as a centralized repository of knowledge to help create value from data, and then both have interfaces to similar tools like Jupyter Lab, RStudio, etc. All right, so the differences are that metrics can be fed, and I think this is probably one of the most important slides of the presentation. What are the differences between the two? What is that versus metric stores versus feature stores? So metrics can be fed to a machine learning model, but features might be meaningless as metrics. Feature stores are optimized for online usage, while metric stores work mostly, although not solely, with batch data. While metric stores sit as a layer between the data storage and any downstream tool, feature stores work for and around the machine learning cycle. So, which means that the feature stores are for an isolated team at an organization, and then the metric stores are for everyone at the organization. So, a team working in feature stores can go and access a metric store, or they should be able to without any issues. But a team working working off the metric stores, they might not be able or might not have the expertise to access the feature store side. So metrics tend to have a long life shelf, while features can come and go as the product and services of the company changes. And then metrics should support simple to complex metrics, while feature stores should make the simplest ones easy to implement to iterate fast and effectively. So let's talk about an example with churn. Churn, defined in the metrics context, is the rate at which customers stop doing businesses with us. And in terms of features and in the machine learning context, churn is just a 1 and a 0. Okay, so for metrics, churn looks like month, total number of users, number of users that churn. So what is churn like? Churn is the churn rate. So churn divided by the total number of users, of active users. So now we have 2%, 1.5, and whatnot. So then in terms of ML, churn looks like I have the ID of a user, I have the gender, I have the tenure, how many months they have been with the company, 3, 30, 42, 10, 25, the total charges that we have charged that person. And then we have the churn. Did this person leave us? Did this person not leave us? And so forth. So that is an example of what these two things look like, or what that problem looks like between both realms. And now for the last part, so how do stores add value? What solutions are out there? And how do I figure out what to look for in them? So the value added, and I'm going to fly through because I know we're almost out of time. So the single source of truth for any downstream tool, hand over most of the feature creation for and process of serving to a single system. Focus on creating and productionizing ML, having metrics logic separated from your tools, monitor distribution shift between training and incoming data for the feature store, define metric as code, and make it so that changes have to follow software engineering best practices, allow data scientists to devote more time to other aspects of the machine learning cycle. That is a big one. So hand off, give people more time to work on the things that they want to do, or the things that are fun at work or more fun. Enable ownership of a metric, and then low latency between incoming data, its transformation, and prediction for the feature store. That's the value that they could add to your organization, plus all of the other things that we have discussed today. So what are your options? For metric store, you have Transform, which is one of the first metric store solutions out there, commercial metric store solutions out there. You have Metric QL, which is one of the first open source tools for metric stores, as a metric store, for you to create your own metric store. Then you have DBT. Then you have Cube.js, which is also an open source solution for metric stores. And then you have Supergrain, which is one of the newest ones, and I believe they just recently started commercializing their product, and they were like in development stage up until a couple of months ago. So that's for metric store. For feature store, we have HubSworks, which they have both a commercial side and a open source side. Then we have Feast, we have StreamQL. Databricks just released their or just launched their feature store offering. We have Cascada, which prides themselves on being the first the first feature store with the best time component in it. We have Featureform, Tecton, and Amazon SageMaker, and by that same note, Google has Vertex AI, and Azure has their own offering. So StreamQL, I believe, is now part of Featureform, or Featureform is the rebranding of that offering. So what do you want to look for in either? And this is the last part. Well, you want Metrics framework. So you want to define and manage metrics once. You want a catalog. You want an interface with the metrics. So remember that I mentioned that not everybody can write code. So you want a catalog where everybody can come in and then put a tag and find the metrics that they want, export it, or interact with it via an API, or I don't know, taking the data however they want. And that way they can avoid writing code. They can avoid writing a metric logic. And then a metric API, meet consumers where they're at. So for the feature store, a single feature definition for production and training. Distribution consistency guarantee between serving and training. This is one of the biggest ones. I do think it's an added value of having a feature store, but if it does, then that's fantastic. Then seamless integration between online and batch serving. So for example, when I want to mention something real quick about that integration between online and batch serving. When a feature comes in and gets transformed and goes to the model to provide a prediction, then it also has to go to the storage. It also has to go to a database somewhere. And then it has to be fed back to the offline side, to the table that stays online. Offline. So when should you adopt a metric store? If you want to empower more people at your organization to take advantage of data, if different teams are making decisions based on the same metrics but with different definitions, and if a lot of the analytics cycle is spent writing queries to get data. When should you adopt a feature store? When ML is not a nice to have in your organization. So if your organization breeds ML, machine learning, and you have a lot of data in your organization and a lot of features, then you might gain a lot of value from a feature store. When online serving is a crucial part of your business, when the number of features your models rely on is too large, or when you need a way to monitor distribution shift between historical and incoming data. Okay, so to recap, metrics allow us to track what matters for our business. Features are the fuel to our machine learning models, and they often need reshaping before we get to use them. Metric stores provide us with a way to write, govern, and serve metrics in a common language. Feature stores abstract away the reshaping of features while providing scalability in both online serving and offline serving. And then if you need consistency, scalability, reusability, and a performance boost in your analytics ML operations, then adopt them. And then I want to leave you with a quote that I came up with, and it's like metric stores, or an analogy that I came up with these two things, or how I think about them. So metric stores and feature stores are like the maestro or the conductor of an orchestra. While the musicians can still perform without one, you can only hope for good synchronization. So thank you very much, and I'll take any questions that anybody has. And yes, thank you very much for listening to me for the last 50 minutes.
Great. Thanks, Ramon. We'll just give everyone a minute to see if we have any questions that do come through. Thank you so much for your presentation. Just a reminder, just whilst everyone's potentially going to ask any questions, a reminder of the check-in link with the event code 15114. So that's where all the resources provided by Ramon today will be in that check-in link. Also, we've got the links to the slide as well, which are also in the check-in link, but easy access just as well there for you in the comments section. And this is an on-demand version available. Will be on our YouTube channel straight after today. So if there's anything you'd like to refer back to, you can that. And I'm just going to put up our slide again, just there if you wanted to check in with the QR code easily. And then also the link to the survey with the same event code 15114. And check out our future upcoming events as well via that link on our meetup page, which is the last one there. So, Ramon, it appears that we actually haven't had any questions come through, which means you've answered all questions throughout your presentation. So thank you so much. Thank you to everyone for tuning in as well. Wherever you joined us from in the world today, have a good rest of your afternoon, evening, or morning, and we'll see you next time for another Microsoft Reactor live stream event. Thanks, Ramon.
Thank you very much. Thank you. See ya. Have a good day.
Bye.